Hello, my name is Gabriel, and today I'll be doing a SLAM presentation on exponent properties. So, first off, just a brief review on powers in case you're not familiar with them already. Essentially, a power will take a number and it'll multiply it by itself that many times. So, if you have 2 to the power of 2, we're going to multiply 2 by itself twice. Or if we have 5 to the power of 3, we're going to multiply 5 by itself 3 times, right? 5 times 5 times 5. And if we have 3 to the first, we're multiplying 3 by itself just once, so just 3. If we have a negative power, it's just, we write it as a fraction with 1 on top, and it's just 1 over the number to that power. So if we have 5 to the negative 4, it's 1 over 5 to the fourth, which is, and 5 to the fourth is 5 multiplied 5 multiplied by itself 4 times. So we get 1 over 5 times 5 times 5 times 5. And if we have 4 to the negative 2, it's just 1 over 4 squared, which is 1 over 4 times 4, as we can see here. And finally, there's fractional powers. These ones are tricky. Basically, it's the number on the top of the number on top of the fraction is what we'll be raising the base to inside of the root, and then the root is of a degree based on the denominator. So if we have 2 to the 1/2, we can see that there's a 1 on the numerator of the exponent, so that means that it's just going to be 2 to the power of 1, and the denominator is 2, so it's just going to be a square root basically. And if we have 2 to the 1/3, it's a cube root, right? And once again, there's 1 on top of the fraction, so it's just going to be 2 to the power of 1. And if we had 6 to the 2/3, it would be 6 to the power of 2, and then we're taking the cube root of that. All right, first rule is the product rule. Basically, the way this one works is if you have 2 to the a times 2 to the b, or I mean, it doesn't need to be 2, it's just a number to a power times the same number to a different power, we can write it as that number to the sum of the powers. So if we had 2 squared times 2 to the third, we can write it as 2 to the 2 plus 3, which is just 2 to the fifth. Okay, why is this? Because if we're going to, we know 2 squared is 2 times 2, and 2 cubed is 2 times 2 times 2. 2 to the fifth, right, is 5 2's. And we can see here, we're multiplying 2 squared and 2 third, 2 squared and 2 to the third. So you end up with 2 squared, which is 2 times 2, times 2 to the third, which is 3 2's. So really, that's pretty much it. And next up is the exact opposite quotient rule. This is when you're dividing two numbers with an exponent, and the numbers have the same base but different exponents, or the same exponent. You can write it, if you had 3 to the a divided by 3 to the b, it would be just 3 to the difference of the powers. So if we had 5 squared divided by 5 to the third, you just do 5 to the power of 2 minus 3, which is 5 to the negative 1. All right, why? What we have here, 5 squared can be written as 5 times 5, and 5 to the third can be written as 5 times 5 times 5. And if you remember, if you multiply, say we have the number 1, and we multiply it by 2, and then divide it by 2. Well, we've gotten right back to 1. If you multiply a number by something, and then you divide by that same something, you get right back where you started. So we're multiplying by 5 twice, and then we're dividing by 5 3 times. So really, we just end up dividing by 5 once, which is just 1/5, which is just 5 to the power of negative 1. So really, the two 5's that we're multiplying by get kind of like canceled out by the 5's on the bottom, and you just end up with 1 5 left over. Alright, and finally we have power rules, which is when if you have like x squared squared, so right, it would be like x to the power of a to the power of b, you can write it as x to the power of a times b. So if you have 5 squared, and then that's to the power of 3, you can write it as 5 to the power of 2 times 3, or 5 to the 6th. Alright, why? We know 5 squared is just 5 times 5, so we have 5 times 5, and this quantity is to the power of 3, which is 5 times 5 times 5 times 5 times 5 times 5. And there's 6 5's, and we know from the definition of an exponent that that's just 5 to the 6th. All right, next up, ones and zeros. This is important to know because these guys can be a bit tricky and they're kind of special cases. Any number to the power of 1 is just that number because it's multiplied by itself once. So 5 to the power of 1 is 5 times itself one time, which is just 5. An 1 to the power of x, it's just like multiplying 1 x times, but because 1 times itself is 1, it doesn't matter how many 1s you have, you always get 1. So you can put a 1 to any power, and it'll return 1. And next, same thing for 0. Exact same thing for 0. 0 to any power will be 0, because you're just multiplying 0 by itself infinitely many times, and that still gives you 0. However, if you put a number to the power of 0, you do not get 0, you get 1. This is just because it's like multiplying that number by itself 0 times. So I guess all that you have there is a 1. Um, I It's a little tricky to figure out why exactly you don't get 0, but I'm not going to go into that for time's sake. Overall, a number to the power of 0 is 1, 0 to any power is 0, 1 to any power is 1, and a number to the power of 1 is itself. Alright, here's some quick practice. So we have 7 squared times 7 to the 4th divided by 7 to the 5th. So first step is you could start by focusing on the 7 to the 4th and the 7 to the 5th, but let's just start with 7 squared times 7 to the 4th. We can use the product rule and add up the exponents, and we get 7 squared, 7 to the power of 2 plus 4, which is just 7 to the 6th. And now we'll do the quotient rule to figure out what this will give us. We'll just subtract the exponents, right? Because we're dividing, so we get 7 to the 6th minus 5, which is just 7 to the power of 1. And because of what we just learned, we know that any number to the power of 1 just gives you that number, so 7 is the final answer. Alright, and one more problem. We've got x to the 4th times y squared, and all of that is squared, over x to the 7th times y to the 5th. Alright, first step is we're going to apply the power rule, and we're gonna basically multiply. We're gonna distribute this 2, because since this entire quantity is squared, we end up having 8 x's and 4 y's, right? Because we're just gonna multiply their exponents. So we get x to the power of 4 times 2 times y to the power of 2 times 2. So we end up with x to the 8th times y to the 4th over x to the 7th times y to the 5th. Now, because of the way multiplication is and how we can say, all right, 2 times 2, or like 1 times 2 times 3 times 4 is the same thing as 4 times 3 times 2 times 1, right? This is just like the commutative property, associative property. We're able to group. We're gonna say, all right, we're taking this x to the 8th, this y to the 4th, this x to the 7th, and this y to the 5th, and we're gonna group them this way. So we're gonna apply the quotient rule for both of them. So we end up doing, we'll just subtract them, right? Because this is a fraction. We have x to the 7th and x to the 5th on the bottom, or sorry, y to the 5th on the bottom, and we have x to the 8th and y to the 4th on top. So we end up doing x to the 8th minus 7 times y to the 4th minus 5, and you end up with 8 minus 7 is 1, x to the 1st times y to the minus 1, right? Because 4 minus 5 is minus 1. Now we know x to the 1st is just x, but y to the minus 1 is 1 over y, so we get x times 1 over y, which is just x over y is our final answer. Thank you for watching this video, and I hope it helped you out. Bye-bye.